Hello, this is Mr. Collier, and today we're using an equation to complete a table and graph a function. So in our first example today, we have a function y equals x plus 3, and we're going to fill out a table and we're going to draw this graph. So we have y equals x plus 3. That's basically a rule telling you how to find the y values when you know the x values. And I like to start off at 0. It's usually the easiest place to start. Now if x is 0, then y is going to be equal to 0 plus 3, which equals 3. So I'm going to put that in here. If x is 1, in the next one here, you have y equals 1 plus 3, which equals 4. So if x is 2, then you're going to add 3 as our rule says, and you're going to get 5, and you can see the pattern down here. We're going to have 2 because negative 1 plus 3 is 2. Okay, so that's a linear pattern because it's going up by 1 each time. It's going up by a constant value each time. And now we're going to graph these points and the line. Well, we've got 0, 3. That's going to be the y-intercept here, 0, 3. We have negative 1, 2. We have 1, 4. 2, 5, and there's our points. We can graph this line now. I'm going to graph this one. Okay, so here's our line. Okay. Now you can always graph a function like this. So even if you have something crazy like y equals x cubed plus 2x plus 3, or something like that, you can always graph this way. So we're going to learn lots of ways to graph functions, but you can always just fill out a table, then plot the points and graph it. That will always work. Okay. Next example, we've got y equals 2x, so y equals 2 times x. So I'm just going to multiply all these values by 2. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 2 times negative 1 gives you negative 2. So there's all of our points. We have negative 1, 2. We have 0, 0. We have 1, 2. We have 2, 4. And there's all our points. If they don't make a straight line, then you've made a mistake. So you can always check your work that way. If it doesn't make a straight line, you've made a mistake when we're dealing with linear functions like this, where you only have x to the power of 1. Okay, so I'm going to plot this here, or graph this here now. It's going to look like it's a bit slow. There we go. So that's what our line looks like. Let's look at the next one. Got y equals 2x minus 3. So I like to start off with 0 here. So if x equals 0, then you're going to have 2 times 0 minus 3, which equals negative 3. If you have x equals 1, then you're going to have 2 times 1 minus 3, which is 2 minus 3 is negative 1. Okay, and then if x equals 2, then you're going to have 2 times 2 minus 3, which equals positive 1. So you can see the pattern: 1, negative 1, negative 3, then you're going to have here negative 5. Okay, so you can see that pattern there. Notice that they're increasing by 2 each time. So we're going to get to that in a second. So we have 0, negative 3. We have 1, negative 5. We have 1, negative 1. And 2, 1. Looks like they form a straight line. So let's graph that line now. Okay. Oops. Let's bring that back down here. Okay. There's a line. So notice on this line, each one you go, for each x value you go up by 2. So we're increasing by 2 each time. That's the rate of change, and notice that corresponds to this 2 here. Okay, so it looks like we've graphed it correctly because the slope of this line is 2, which is the same number we have here. Okay, And you can also notice that this negative 3 in the equation corresponds to the y-intercept here, which is negative 3. Now let's take a look at our next equation. Okay, now this one might be a bit tricky. Alright, so we can do it the same way though. We'll figure out what the y is when x equals 0. So we have x equals 0. Now if we put that in the equation, we have 2 times 0 plus y equals 1. So you have 0 plus y equals 1. You just have y equals 1. If x equals 1, you're going to have 2 times 1 plus y equals 1. So it's 2 plus y equals 1. So you subtract 2 from both sides. You have y equals negative 1. Okay, now there's an easier way to do this. You don't have to do all this algebra for each single x value. What you can do at the beginning is you can solve for y here by getting this x over to this side. So what we're going to do is we're going to take 2x plus y equals 1. We're going to subtract 2x from both sides of the equation. And what we get is y equals 1 minus 2x. Okay? So that's an equation solved for y, so we can use that when we're finding our points. So x equals 2. We're going to have y equals 1 minus 2 times x, which is 2. And then we just work that out. That's 1 minus 4 is negative 3. So our next value is negative 3. And this is negative 3, negative 1. Looks like if we go backwards here, we're increasing by 2, so that's going to be a 3 there. Alright, so if you have this, look at this equation, you're going to have 1 plus 2 is going to be equal to 3, so that works out. These points, if I graph them, I'm going to have negative 1, 3, 0, 1, 1, negative 1, 2, negative 3. Okay, so they do all line up, so it looks like we've probably done this correctly. And I'm going to draw the line here. Okay. So notice this line is going downward to the right. Okay, so if you look at the coefficient of x in our equation that's solved for y, notice that the coefficient is negative 2. That means that for each x we go over, we're going down 2. Okay, so the slope of this line is negative 2, which is the same number in front of the x here, and this here value is 1. That's the same as the y-intercept, which is right there. Y-intercept equals 1. Okay? So slope is negative 2, the y-intercept is 1. If you forget all that stuff, you can always just use your equation to fill out table values and then plot the points and graph.